our CLO for these notes, our students will be able to solve in writing for a single variable using inverses and the following language, if-then statements, isolate, inverse, and eliminate. So to start with our vocabulary, the word isolate is just a very big word that means solve for. So when we're solving for x, we're isolating x. But another way to think of it is to get alone. So if you're isolating something, it's going to be all alone. Remember, inverse, the inverse of something undoes it. So for example, adding and subtracting are inverses because adding undoes subtracting. And when we're undoing things, what we're actually doing is eliminating it or getting rid of it. To eliminate is to get rid of, cancel. All of these mean the same thing. All right, so we are going to be solving for x. What is x? Well, in elementary school, you might have seen x standing for multiply. It will never mean this again. If we're saying multiply in high school or anywhere above elementary school, we usually use, like, if I want to say 3 times 5, I use a parentheses for multiply. And I don't want to put an x there because then it kind of looks confusing because we use x's in high school for other reasons, for reasons that don't mean multiply. So never use an x to mean multiply. In middle school, it starts to become stands for a number we don't know. So in a lot of middle school math, x just means it's a number we don't know and we have to figure out what it is. And then in high school, and you'll see as high school gets harder and harder, that x stands for the independent variable of time. You will learn this much later on. It doesn't matter for today's lesson because for today we're going to use the middle school definition. So we're going to use it to mean a number we don't know, and we have to figure out what that number is. So in this example, 1, when we look at it, it's saying there is some number, we don't know what it is. But when we add 3 to it, it should equal 5. So the logic, and we can do this pretty logically, what number plus 3 equals 5? The answer is 2, because 2 plus 3 is 5. And that makes it true. But let's say I didn't know that for some reason. And so I want to isolate x and get it all alone, and that's my goal. Well, remember the equal sign counts as a wall that cuts the 2 sides in half. So this is one side, and then the 5's on the right side. So right now on the left side, x is not alone. There are things there's an x, and then there's a plus 3. I want to eliminate this plus 3. How am I going to get rid of adding 3? I'm going to use the inverse of adding, and the inverse of adding is to subtract. But remember, if I ever bring my left side down by 3 to make sure my 2 sides stay equivalent, I also have to bring my right side down by 3. So now, when I do the math, I have x. This plus 3 minus 3 eliminates. I still have equals. On this side, 5 minus 3, if I don't know, I could always put it into a calculator, is 2. So then I would find out that my answer is x would have to be 2 to make this equation be true, where 2 plus 3 equals 5. So our goal when we solve for x is we're trying to figure out, what does x have to equal? What number do I have to put right here instead of x to make sure that this side does actually equal whatever's on the right side? And so it has to be 2 in order for this to actually equal 5. And even though it's really easy to do logically, eventually it's going to get harder. So it's important to practice it the math way. Let's do another one. Logically, this is saying, when it's saying x is some number we don't know, some number, something, minus 1 equals 4. What number, when I minus 1 away, is it going to equal 4? The answer is going to be 5, because 5 minus 1 is 4. But if I didn't know that, and I need to isolate x to figure it out, the inverse of subtracting 1 is what? Adding 1. So if I add 1 to both sides, it keeps it balanced. But then over here, minus 1 plus 1 eliminates, it cancels. So then I'm only left with x equals, and then 4 plus 1 is 5. And that's how I'd figure out that 5 minus 1 would give me 4. So that would be the answer to this one when we solve for x. Let's do another one. All right, so the logic here is that negative 2 plus something equals 8. What do you think it is? Well, let's solve. So right here, this is a negative 2, which counts as a minus 2, and the inverse of subtracting is adding. So I'm going to add 2 to both sides to keep it balanced. These 2 eliminate. So then now I've isolated x. It's all alone. And x equals 8 plus 2, which is 10. So then that's my answer. And to quickly check it in the calculator, if I have negative 2 and then I add 10, it equals 8. Just like if I take negative 2 and add the x, which we found to be 10, it would equal 8. All right, last one. So this logic is saying 9 plus something equals 18. 9 plus what equals 18? 9 plus 9. 9 plus 9 equals 18, see? But let's pretend we didn't know that. So I have to isolate it and get this x all alone. Right now there's still a 9 that I need to get rid of on the left. How am I going to get rid of it? By minusing it away to both sides. So this 9 minus 9 eliminates. So I've officially come here and isolated x. It's the only thing on the left now. And 18 minus 9, if I were to put that in a calculator, I'd get out the answer of 9. So in this case, the answer is that x equals 9.